All right, so we're here on malware analysis. Starting at samsglass.info, there's a link to the malware analysis. And the first thing is getting a Windows VM going, which several students have finished, where you get Windows 10 or Windows 11 with a bunch of analysis tools pre-installed. You could also use a plain Windows machine and install the tools yourself. All the tools we're using are freely available. The first thing we're going to do is Process Explorer. The whole point of today's workshop is to learn how to analyze Windows malware, and really that's mostly learning how Windows software works, so you can understand how malware is abusing it. So first we're going to just make a simple program and analyze it with Process Explorer. So I'm going to move this to the side and demonstrate it in my private cloud machine, which is here. Looks like I need to reconnect to it because this machine, its product key has expired, so it does shut down if you neglect it for an hour or so. So I'm restarting my Proxmox cloud machine, and the CPU goes up, and when it comes down it's ready to go. Okay. And the no VNC console is the one that works. I don't know what that spice thing is, but it doesn't work as well. All right, so now I've got my cloud machine here. Okay, and so looking at PMA 105, Process Explorer is a tool that lets you see all kinds of information about running processes. Now, we're going to make our own software, so for that you need a compiler, and we're using Visual Studio, which is a free download. And if you are using a machine you made yourself, you'll have to first install Visual Studio, which you'll see is down here, installing Visual Studio. There's a free version called the community version, and you could install the latest version, which is 2022, or the older version, which is 2019. It doesn't matter. And by the way, you can do all this on any version of Windows, Windows Server. All the stuff we're doing here is fundamental to the operation of Windows. It's not specific to any particular version. Now, here is a strange thing about Microsoft Visual Studio. If you want to compile things from the command line, you can't use a normal command prompt. You have to go to the Start button and find your way to the old menu of programs, which is a little annoying on Windows 11, although Windows 10 it's right here. And then you have to go to find V, and in the Visual Studio container, expand it, and there's a bunch of command prompt launchers. And what we want to write here is 32-bit code, so we're going to use the x86 native tools command prompt. This is the strangeness of Microsoft. You load this, and you're in a command prompt, but it is a command prompt in a specific directory with some environment variables set or something. Somehow you have to use this command prompt, not a default command prompt, to do this work. And now you can create a program. So I just put it in a folder called 99. It's already on this machine, but the project shows you make a directory and go here. And the code we're going to make a simple file. Let me remove the compiled copy with delete. I've already done the project on this machine, and I'm going to delete the results 99.object and delete 99.exe. All right, now if I do a directory, all I have is the CPP, and to see what's in there, you can use Notepad, and this is how you make it. You Notepad 99.cpp for C++. Whoops. And this is the code. This is basically hello world. All this does is import a namespace that lets it use standard tools, and then it prints 99 bottles of beer, and then press enter to continue and wait. So this is just going to print something and then not close, but stay open. And you compile this with CL. This is the standard command line compiling, CL, and for some reason the EHSC switches are recommended. I'm not sure you always need it, but anyway, they work. This is how you do a command line compile of C++ code with the Visual Studio command line compiler. So there it is, compiling the code, creating 99.object. it's created object code and executable code, and you can see the source code is only 225 bytes. The object code, which is the compiled code without the libraries, is 1900 bytes, and the final executable with everything is 104,000 bytes. And if you run that, it prints that message and then waits for enter to continue. If you press enter, it stops. I'm going to run it again and not press enter because I want that process running, because now we're going to examine what a running process looks like in Process Explorer. So I'll minimize this to get it out of the way and then launch Process Explorer, which is a free Microsoft Windows download from sysinternals, which provide a whole bunch of wonderful tools for Windows, and Microsoft brought the company. So it's now included in its free Microsoft tools to download. There's a Process Explorer, and on a 64-bit machine like this, I'm using Process Explorer 64. They both work the same way. And Process Explorer helps you understand how Windows works. This shows you all the running processes on your machine in the order in which they boot up. So remember a couple days ago doing forensics, we talked about the Windows registry. The Windows registry has to be built during the boot up process. Then it loads the system. Then it starts Windows with WinInit, and all kinds of components of Windows are started. Then, after all that, it goes to WinLogon. So all the things above this WinLogon happen before you log in, and therefore they're all running with a generic account like System or Trusted Installer or something, or Network Service. These are all happening before anybody's logged in. Then you get to WinLogin, and you log in with your name and password, and now it can run things as you. And you notice the color changes once Explorer appears. Explorer is the process that draws the desktop and the start button and everything you launch. So after you log in, Explorer is where you actually start being able to initiate processes by clicking on icons and executing commands, and all those show up here with the blue color. This is called user land. This is mostly kernel land, code running that's the system running with high privileges for an internal process, not something that is launched by the user. So everything you do is down here in user land, and here you see I launched a command prompt CMD. It launched something called conhost, and then here's the 99.exe process running. Then there's other things running like a Java update process and so on. So if I click on the 99.exe here, it just highlights that line and shows how much memory it's using and the process ID number. Every process on Linux and Windows has a process ID number, and you can use that to refer to it in command line commands to do things like kill the process. Anyway, I can learn more about this process by viewing the lower pane. If you turn on Show Lower Pane, it will show you more details about the selected process. And here, it's showing me the libraries it's using. The DILs are dynamic link libraries. The other thing you can see in the lower pane view is handles. Handles are all the little named objects it refers to. In this case, it's directories and a few files and some kind of registry key associated with this process. So that's the first thing you do, just to see some facts about a running process. And let me bring the instructions back. All right, I guess that's fitting well enough in the screen. And so there's a flag defined here having to do with one of the DILs. And now we're going to try something else, which is, I was very charmed to learn about this. If you right-click a running process and go to Properties, you can see a lot of information about running processes here. Here you see general information about the image and what folder it's in, but the part that really got my attention was strings. As you probably know, if you run the strings command on any file, it will find all the readable text in that file. That's what this does right here. So right now it's looking at the image, which is the hard drive file. Now when you launch a program, we had this program called 99.exe on the disk. There's a copy of this 104 kilobyte file on the disk. When you launch it, by typing this 99.exe and pressing enter, it copies that executable into memory. The copy in memory should be almost identical to the copy on the disk. It's not exactly identical because, as we'll see, it breaks the segments into pieces and puts a different gap between the segments, but all the internal segments should be bit for bit compatible. So the strings in an image in memory should match the strings in an image on the disk. So here's the strings on the disk. There's a bunch of random strings here. And if you scroll down, somewhere will be the messages I typed. Now here's some messages that come, some names of Windows libraries having to do with date, time, and such. And then there's some date and month names that are included. Here's a bunch of language names that are used by Windows libraries because Windows is an international operating system and can operate in all these different languages. And here's the strings I typed: 99 bottles of beer on the wall, 99 bottles of beer. And now here's the names of some C libraries that are being used. It's a very good idea to get used to what this looks like. As you get into malware analysis, and for that matter, capture the flag contests, you often look for strings in a file, and it's very handy to know what kind of strings you'll see in a harmless, innocent file like this. Here's another bunch of low-level Windows process names. Windows API calls always look like this, a bunch of words capitalizing each word and ramming them together. And by the way, often ending with EX or W. EX means this is an extended version of a function that existed in an earlier version of Windows, and W means this uses wide characters, which are 16-bit characters, instead of A, which would be ASCII characters, because Windows started out as an English-only operating system running ASCII, or perhaps that was when it was MS-DOS, and then they migrated functions to use 16-bit Unicode, which is what Microsoft uses for its international system. It's a very old version of Unicode and very limited, but that is what Microsoft standardized on back in the 90s, and they're still using it. So anyway, those are the strings on the hard drive, but you can also examine the strings in memory. And for a simple program like the one we've made here, they're just a copy of the same thing. That's what they should be. The strings in memory should match the strings on the hard drive. But there's an attack called process hollowing, where you take a running process and you change the memory contents of it while it's running. So now you can continue to run with the same privileges under the same name, but the actual code running in memory does not match the process on the disk. And if you did that, these two would be different. So anyway, that's all I wanted to show you about this 105 Process Explorer. I'm going to stop this video.